Welcome. This is 1.3 measuring segments, so make sure that you have this header right here at the top. And so let's get started. The first thing that we're going to talk about is, and you don't have to write this down, this postulate, normally we do write these down, but this one, let's just talk about it really quick. It says, and I'll read it really quick, it says every point on a line can be paired with a real number. This makes a one-to-one correspondence between the points on the line and the real numbers. The real numbers that correspond to a point is called the coordinate of the point. All this is saying though is if we have a segment, we could use like the ruler postulates in order to measure the lengths and then in order to figure out the distance between the 2 points. So you don't got to write that down, but we are going to write this down at the bottom. So let's have you write down just this one sentence that we have right here about distance. So it says like the distance between A and B is the absolute value of the difference of their coordinates, or A minus B. And so I would write this last sentence right here down, and then this picture over here. It's kind of helpful. So all it's saying though is we can measure the distance between these 2 points, and we take the absolute value. Remember, when we take the absolute value of a number, it's always positive. So anytime we're talking about distance, distance is always positive. So if I say how far away is my house from the school, I wouldn't say like negative 20 feet. It would just be like 20 feet. Distance is always positive. So again, when we're measuring the distance right here, it's absolute value because I want a positive number. And the next thing that we're going to write down is we're going to write down this box that we have right here, our segment addition postulate. Okay, and so this is like pretty straightforward, but it's definitely a really important one that we're going to be using. And it says if 3 points A, B, and C are collinear, which just means if you have 3 points on a line and B is in between A and C, then AB plus BC equals AC. So again, I would write this down and I draw the picture. All it's saying though is if we have these 2 segments and we add them, combine them together, then they're going to equal the whole segment AC. Okay, so again, AB, and if I add that with BC, it's going to equal AC. And again, we show that through this one. So we're going to be using some algebra in order to be able to figure that out. But this is definitely a really important one that we're going to need to know. Alright, our next vocab that we have right here is we're going to write this down about congruent segments. So it says, if 2 segments have the same length, then the segments are congruent segments. So again, I would write that down, and I would probably draw this picture that we have right over here, everything right here. You don't need to write this sentence down right here, but all it is saying though is if these 2 segments, if you have segment AB and segment CD, they're both 1 inch long though, right? So they're the same exact length. So we would say that these 2 segments are congruent, means they're the same length. And a way we show congruency though is when we mark a line right there, those both have 1 line, just telling us that those 2 are congruent. You'll also see, and it's a little unclear right here, that this is an equal sign, which means that these 2 segments are equal. But again, when we're talking about congruency, you'll see that we have this congruency sign where it looks more like this, where it's an equal sign with this little squiggly line, just like that. So again, when we're talking like with numbers though, we're saying that these 2 have equal numbers. But again, especially more when we get into proofs later on in the semester, when we're just talking about like segments and different things like that, we would say that they are congruent. Even though they don't have numbers right there, if we've already proved that they are congruent, we would use this sign that we have right here. Okay, it just means that they're the same. Alright, next thing that we are going to write down is I would write down all this, our definition, and I would even draw the picture. The picture would be very helpful. So it says the midpoint. The midpoint right here of a segment is a point that divides the segment into 2 congruent segments. So the midpoint is the middle. Midpoint, makes sense. So it says a point, a line, or a ray, or other segment that intersects a segment at its midpoint is said to bisect the segment. So all you're saying though is that we have this line, if you look right here, this line is bisecting, which just means it cuts the segment into half. That point or line or ray or segment is called a segment bisector. So we would just say that this line L, would be bisecting AC. Just means it's cutting it in half. And where does it bisect at? It bisects it at the midpoint. So again, a lot of vocab that we have right here, but again, do you see how we have these two lines that we have right here? These two lines are telling me that this AB right here, that length right there, and this length of BC segment are the same. So again, they are the same, which means that they're congruent, which means that this line cut it right in half, which means it was a bisector, which means it bisected it right through the midpoint. So, out of vocab. Alright, so let's get into some problems really quick right here. So our first problem, again, I would write problem number 1, I would write down the question, and I would draw this picture that we have right here. So it says, what are UV and SV on the number line? So it's just asking what is the difference, what is the length of this segment. So there are two ways that you can do it. We can count it, or we can use our absolute value that we learned in the very beginning that we have right here. So if I was looking at UV, let's change this to black. Let's go black. So let's say I have UV, I have the segment, UV, and again segment, I put that over the top. Let's say we count it. We're given a number line we can't count. So just be careful. This number right here, you see it's going up by 2 every time. So if I start at U and I go to V, so there's 2 that we have right there, and then there's another 2 that we have right there, 2 and 2, so a total of 4. So the distance of that segment is 4 units. But remember, we can also use our absolute value, which is important to know. So let's do that with the next one. If we have SV that we have right here, again, remember the absolute value is from these two numbers. You would combine those together. You would take the difference. You would take the difference of those numbers. So remember, we had that formula. It was in the very beginning of our notes, at the very bottom of that first page. And if we take the absolute value, and if we start at S, we have -4. And if we take the difference of where we want to end up at V, which is 14, we have the absolute value of -4 minus 14. So again, remember, however your algebra teacher or 7th grade teacher taught you about integers, both have negative signs, so this is really just going to become the absolute value of -18. And then anytime we have an absolute value, again, it's always going to be a positive. When we're talking about distance, distance is always positive, so this is going to equal positive 18. So again, SV right here, that segment is 18 units, and for UV right here, it is going to be 4 units. Alright, so our next problem. So problem number 2, write it down, draw the picture. So it says, in the diagram, we have the segment JL, and it's 120. What are JK and what is KL? Okay, so again, it's helpful, like, it's not really, we have to use like our algebra skills and what we've learned so far in order to solve this problem. It's helpful. So what did it give me so far? It gave me that JL was 120. So like, let's draw that out. So from J to L right here, that is going to be 120. So remember, at the very beginning we had our addition segment postulate, which just means that if we have one part of the segment and another part of the segment, then it's going to equal the total part of the segment. So if I'm looking at this, if I take this JK, this portion of that line, and then I take this KL, that portion of the line, and if I add those together, it's going to equal JL, the total portion. So now we just have to set this up as an equation in order to solve. So JK, and again, if you wanted to write it out, you could say that JK plus KL is going to equal JL. And again, we are talking about segments, so we put little segments over the top. Okay? And so again, now we're just going to fill in what does JK equal. Well, JK equals 4x plus 6. And then we're going to add that with KL, which is 7x plus 15. And then what does JL equal? Well, it told us in the original that it was going to equal 120. So now we just got to solve for x. So we're going to get 11x plus 21 equals 120. And then now just a two-step equation. Subtract 21 from both sides, and we are going to get 11x equals 99. Again, if you have a calculator, this is super helpful to make it really easy. But then if I divide both sides by 11, then x is going to equal 9. And then we're thinking, yes, good, we're done, right? Not yet, because again, we have to read the question. The question didn't ask me what x equals. It says, well, what are JK and KL? What are those lengths? So what I need to do is I need to take whatever x is and plug it back in to figure out what is the actual distance of that segment. So if I was doing it, and we'll do it down here, if I have JK, this is going to equal 4 times, and x was 9, plus 6. And so that's going to give me 36. 36 plus 6 is going to equal 42. I believe so. And then the other segment was KL. KL is going to equal 7 times 9 plus 15. And this is going to give me 63. 63 plus 15 is 78. And I'm thinking, did I add those really quick? What should both of these numbers add to? Well, they should add up to 120. So if I do 78 plus 42, boom. I even have my calculator on my phone right there. Boom, 120. They do equal, so I feel pretty confident that I got this problem right. Cool. All right, next one. All right, last problem. Yes, we're so close right here. All right, so our last problem is, again, write this down, write that. I think this is problem number 3 that we have right here, so write that down. So it says Q is the midpoint. All right, midpoint. Those are one of the key words that have midpoint, means it's in the middle that we have right here. What are PQ, QR, and PR that we have right there? Okay, so remember, in the last problem that we had right there, the two lengths weren't equal to each other. They were different lengths. One was 42, the other one was what, 58, something like that. They were different lengths. This one is different though. This one is saying that this Q right here is right in the middle, which means that this PQ right here is the same exact length as this QR. And again, we can use those lines right there to tell me that both those lengths are congruent. And if they are congruent, it means they are equal to each other. So if they are equal to each other, they have the same length, then I can set both of these equal to each other. So that's what I'm going to do. I'm going to take this 6x minus 7, and whatever length, whatever number that is, once we find that out, that should equal the same length as this one, which is 5x plus 1. Okay? So again, we got to use our pictures in order to set up equations that we have right here. So again, I'm going to solve this equation. I would first subtract. Let's get all the x's on one side. 5x to both sides. This is going to give me x minus 7 equals 1. Then I'm going to add 7 right here to both sides. That was a terrible 7. And we're going to get x equals 8. Okay, again, 8 is not my answer. It wants to know what are the lengths of both of these. So we need to take this 8 right here and plug it back in. So if I'm looking at this length PQ, it wants to know what is segment PQ? PQ is 6 times 8 minus 7. And let's just use a calculator. So I'm going to get 48 minus 7, 41. Boom. And again, well, we said these lengths have to be the same, right? So QR also has to be 41. But let's just multiply it out just to make sure. 5 times 6 is 30. 30 plus 1 right here is not 41. What did I do wrong? Alright, duh, I plugged in the wrong number. That was stupid. Alright, so let's erase this right here. I was looking at the 6 over in this top one, and I just plugged that in. Again, easy to make mistakes. But this should be 5 times 8, because we said x was 8. So 5 times 8, which is 40. 40 plus 1 is 41. So again, I knew right there those two lengths had to be equal. So I know I did something wrong, because those have to be the same numbers. And if it wants to know, well, what is the length of PR? PR right here, again, we're talking about segments. Well, PR is both of these combined. So if this is 41 and this is 41, then when I combine those together, it's going to equal 82. Boom! Done, that we have right here. You guys did great. See the bookshelf that I have right over there? Yeah, it makes me look nice and smart that I have right here. Just like you guys. Thanks for watching the video. We'll talk about this soon. Clarify any questions you guys have. Alright, see you soon.